So can I introduce you to Dr. Jeff Davis? Jeff is Vice President of Strategy, Marketing and Technology for HORIBA MIRA. So
as per Brady's introduction, I'm an engineer by background, been in the industry for about 20 odd years, formerly Ricardo, then MIRA, and then subsequently the sale of MIRA to HORIBA means I'm part of the global team that runs their automotive business globally. The organization I work for, HORIBA, Japanese tech company, very much focused on measurement solutions, quite a significant business, and they own the MIRA business, which is UK based and renowned for engineering and testing. More recently, certainly around electrification, fuel cells, CAV and cybersecurity. Right, so I'm going to talk about a specific a narrow subject with regards to simulation. That's around vehicle resilience. So vehicle resilience is the combination of a number of disciplines that ensure we can engineer increasingly complex and automated vehicles in a safe manner, which ensures robustness, resilience, and should they fail operational or safe. And it's largely the combination of electromagnetic compatibility, functional safety, and cybersecurity. So simulation is clearly an area of interest here, and it's a growing and essential part of engineering robust systems for current more complex vehicles. So there's a couple of points I want to make with regards to the fact that the challenge we have is increasingly more complex. So without simulation, we can't survive. Simulation tools we are using are becoming increasingly practicable and useful, and it's complementary to measurements. So if I go back to the theme of the webinar today, simulation is an essential part of the robust systems engineering approach we take within vehicle resilience, and neither measurement or simulation is good enough on their own. So would I put my life in the hands of a simulation validated system alone? Well, with regards to VRES, no. I'd insist on a combination of simulation and measurement, and that's really the approach we take. And we use simulation to its strengths and allows us to really compress the validation cycle. We do not use it alone. So simulation is needed due to the size of the engineering task we face. In the world of VRES, there frankly is no alternative to using a simulation-led approach. We're dealing typically here with increasingly automated and connected vehicles, and the technical challenge is significant. I mean, we've all heard the stats of how many hundreds of millions of line of code modern vehicles have, over 100 ECUs on a platform, more than 15 antennas on a premium vehicle. So the size of the task is significant when we're validating these. But it's not only due to the rise of the technology, but it's also how the technology is integrated into the vehicle. So for instance, we can run a component or system test, and a component or system or module may pass, but once it's integrated into the vehicle, will fail. And that's because many of the vulnerabilities, once integrated in the vehicle, become apparent. And you tend to introduce new vulnerabilities as you integrate these systems. So without simulation, it's really difficult to get the root cause of an issue. And without simulation, it's impossible to test all the scenarios. So if we talk about CAVs again, we hear regularly the tens of or hundreds of millions of miles that CAVs will require for validation in the real world. Obviously that's of interest to us to bring that into the simulation world, but they produces so many different scenarios, and there are so many different scenarios that place demand on vehicle-borne systems or maybe non-vehicle-borne systems that we have to replicate from a vehicle resilience perspective. So without simulation, it just simply is impossible. The other challenge we have is that in addition to the compressed or the increasingly complex vehicle, we also have the continuing desire for compressed development cycles, and also a shortage of skills, and particularly within this area of the areas of cybersecurity, functional safety in particular. And I imagine once this the COVID pandemic has settled down, we're likely to be left with less engineers on programs, but the program complexity is not going to go away. So without simulation, how are we going to deliver the bulk of the work? So we really clearly need strong simulation tools in this space. And then and with such a variation in access to people and skills, it's impossible to run a consistent validation process, and we need software to help us run the process. So software, we find now that software tools in this particular space have to have the inherent knowledge, so we don't have to rely necessarily 100% on having the right skills in place, but we have a reasonable degree of confidence that we can deliver a consistent validation process. And then third point to make here is that we very much typically focus on the vehicle, but with the world of connected and increasingly automated vehicles, it's not just the complexity of the vehicle, it's also the complexity of the ecosystem, and the fact that the vehicle is integrated heavily with that ecosystem. So previously, we're focused on vehicle-based systems. Now we have to worry about the Internet of Things, back-end systems, transmitters, etc., all of which have potential to cause issues. And that's really a new challenge for our traditional automotive industry, where we're focused on the vehicle. And the skills that understand that ecosystem are really only redeveloping in the automotive industry. So we really need good software tools to help us support the engineering process. I'd also say simulation is more practical. There's great availability of data now, and the more data we have, I mean, in some cases, more data than we know what to do with. And so some of the challenges we have, particularly in this space, is how do we manage all that data? What are the various sort of vignettes of data that really give us what we need so we can tune our models? But I'm glad to say that software is really coming on quickly in this space to making that job easier. And of course, you have increasing computational capability and availability. And the next point I make on this slide, and the final point, really is about how simulation is complementary to measurement. I alluded to this earlier. Measurements by definition are inherently inaccurate, and I would say none more so than in an EMC environment. That's a really good example. We can be 50% off in any one measurement because of what you're measuring it with, and the environment that you're measuring it in. And these, if this was a safety critical system, that can cause us a real headache. So we tend to use software to help us fine tune our measurements to ensure that we can remove various actors from the scenario and what we're measuring, and our modeling is successful, our measurement is successful. To give you an example, to conduct a suitable validation exercise on a vehicle, now we can do it in a week. If we were to do that by test alone, it would be over 2 years. Okay, so the key point to close the slide is that that simulation within VRES is not just critical from a pass-fail perspective, it also has a critical part to play from a cost perspective as well, and a brand perspective. Now, we have huge costs at play should we delay the introduction of a vehicle or production of a vehicle by a few days because of a non-validated software feature that's maybe safety critical or component. And particularly from a complex subject matter perspective like VRES, there's also a cost to brand if we get it wrong. If you have something that fails and fails catastrophically, potentially causing a loss of life, then that's a major brand issue as well. So huge financial implications as well. And so I'll just close the slide by saying, to successfully engineer resilience, we have to have all the available tools available, and simulation is a really key point. So you may have seen this in the media recently. On behalf of Zenzik, MIRA has led a major R&D program in conjunction with some key partners, notably BT and Thales, and that's been a study into the future cybersecurity needs of the automotive industry in the UK, and the results have been published. And simulation is one of the key 6 components of a future testbed ecosystem. So building on the recent investment in the CAV ecosystem that we've had. In this study, we highlighted the need for simulation in 3 key areas. We need a sense of excellence that covers simulation and virtual engineering, and it must generate the skills because we have a critical shortage here. If we don't develop the skills in the UK, we will not meet the challenges we face. And these are skills not only with the subject matter, but using the simulation tools that we really require to robustly engineer products in this space. There's a lot of great work being done, Davis, from Thales, and this is really rewriting the science in this subject matter. The work being undertaken is trying to better understand what the threat is and how you can deal with it in the quickest possible time. And to do that, you have to react before a catastrophic event may occur. And in order to do this, then not only do you have to rely on historical data, but you need to try and predict the future. And therefore, you're using significant computational resources, game theory, and simulation tool sets. So simulation here has a real critical role to play as we try and manage cybersecurity risk in a real-time manner. And then the third point is that we really need to understand the infrastructure, extend our simulation into the infrastructure so we can understand the infrastructure better. So final slide. So there's so much going on in the industry and so much churn that we really need simulation tools to help us here. Now, from a cybersecurity perspective that exist across different systems, different suppliers, etc. We really need simulation tools to allow them to quickly make decisions and understand risk and threats. At the moment, that can take weeks because you just can't get hands on the data. And if we don't have the systems in place, you tend to lose the knowledge, and you don't have also the skills in place. So we're relying on smarter simulation tools to help us here. And with the right tools in place, we can make decisions quickly and become increasingly prevalent in this space of trying to manage cybersecurity risks and ensure resilience in our platforms and products. Okay, thank you, Philippa. Thank you.
Great, thanks, Jeff. I really liked your points there about using simulation to sort of compress the validation time, but also the emphasis about the modelling of the different scenarios and helping to look at how you can analyse, help engineers analyse the challenges and really look at that root cause, but also the emphasis on skills, which I think we'll all agree is a very important challenge for all areas of the technology. So.